Welcome. This video introduces AR Express, a free application that integrates Google SketchUp, Google Earth, and Google 3D Warehouse with Microsoft's Robotics Developer Studio, or RDS. When you want to prototype a robot using the RDS simulator, you write code or scripts to create a scene and place your robot in that scene. With AR, instead of writing code or scripts, you do this graphically using SketchUp. What you are looking at is Google SketchUp with an empty work area. Along the top are the tools that you get when you install the AR plugin. Using these tools, you can easily create single shape entities, joints, actuators, and sensors. The first thing we're going to do is click on the ground tool to create the ground. Let's keep the default color and texture. Next, let's create some single shape entities. First, I'll create a box. Then I'll create a capsule. And also a sphere. Now that we have created some simple shapes, let's export this scene to the RDS simulator. To do this, just press the F5 key. Next, let's bring up Visual Studio with an AR-enabled project. An AR-enabled project is a DSS service using the AR Core DLL. This DLL reads in all the entities that you created in SketchUp and transforms them to their native equivalent in RDS. To run the project, press the F5 key. As you can see, the entities that we created in SketchUp are now in the simulator with the same position, orientation, color, and texture that we have in SketchUp. Also notice that the camera in the simulator has the same position and look angle that we have in SketchUp. Let's close this and go back into SketchUp. Let's create a joint. You have several joints to choose from. Here I'll use a hinge joint by clicking on the hinge joint tool. I'll place the joint here and orient it this way. With the joint selected, we can attach both the capsule and the sphere to the hinge joint by selecting the entities you want to attach and select Attach Entities to Joint. Let's export again. And in Visual Studio, run the project. As you can see, the sphere is rotating freely around the capsule. All entities and joints in SketchUp are configurable. To configure something, like a joint, just click on it to select it. Then right-click to configure it. Let's add a drive and a spring to this joint. Now let's create a servo controller board. We'll place it on the box. Let's name it SC for servo controller. Now I'll attach the drive to the controller and export and run the simulation. When you run an AR-enabled project, a control panel opens. The panel allows you to control the entities that you explicitly named in SketchUp. Since I gave the servo controller a name, it will appear in the drop-down, and we can use it to control all the attached drives. For the hinged drive, I can rotate it by sending orientation commands to the drive. AR is integrated into the tools of SketchUp, so you can use them as you normally would. Let's use some SketchUp tools to create a very simple mesh to represent the rotating ball of the robot. First, I'll use the arc tool to create an arc. Next, I'll use the line tool. Next, I'll use the push-pull tool to raise it. By triple-clicking, every face and edge attached will be selected. Now group all the faces and edges. Let's color the mesh red. We can now set the mesh to be the visual representation of our ball. To do this, just click on the ball, then holding down the Shift key, click on the mesh. Right-click and select Attach Mesh. Then position the mesh over the ball. Okay, now let's resize it. Of course, you will use a much more realistic visual representation, but this does illustrate the point. Let's export and run the simulation. Now the ball has both a physical representation and a visual representation. When I render in combine mode, you can see both representations. You can see the physical representation, the ball, and the visual representation, the mesh. As I move the ball, the mesh follows with it. Using AR, you can easily create 6 or 7 axis robotic arms. Using a similar process, you can create large, complex humanoid robots, such as Asmo, with over 40 servos and an array of sensors. Now let's create a differential drive. A differential drive has 3 physical entities: a wheel axle, a caster wheel, and a chassis. First, let's create the physical components of our differential drive, starting with the wheel axle. We need to resize it to fit the dimensions of our vehicle that we plan to create. Let's set the outside diameter between the wheels to 12 inches. Now let's set the diameter of the wheels to 6 inches. We also need a caster wheel represented by a sphere. Let's set its radius to 3 inches. Finally, we need a chassis, which is represented by a box.